DSD Confusion. Well, Colin in Princeton, New Jersey, I guess home of the very famous Princeton University, writes to us and says, I'm a listener to DSD audio, but I'm confused by the format. As I understand it, DSD records 1-bit samples millions of times per second, depending on the rate of DSD. Contrast this with other high-resolution formats, for example, 2496, 24-bit samples, 96,000 times per second. What is it about 1-bit samples that makes DSD sound so great? I think if I can understand that, I'll have a better understanding of the format. Thanks for all you do, Colin. Well, you're most certainly welcome, Colin. And we are sitting in one of the few all DSD studios, Octave Records. Gus Skinnis runs that. This is a Sonoma mastering system and recording system. We record everything and master everything in DSD because our belief has always been that DSD is by far the best sounding format in the world, and it's much better than this 2496 that you're referring to, which is what's called PCM. I think the basic point that people kind of miss, because there's so many confusing terms, right? We hear 1-bit sample. What the hell is a 1-bit sample? How could you take 1 bit, which we know a bit is it's either a 0 or a 1, right? So how do you measure anything like music? How do you take that on a microphone and using 1 bit sample anything? It just doesn't make sense. A bit is on or off, right? Well, that's where the confusion comes in, because these terms that we don't fully understand. So what I recommend, if you really want to know what DSD is, do a quick Google search for PDM, pulse density modulation. That's what DSD is. And compare that to PCM, which is pulse code modulation. Now, I will do my best to explain it, and I'm going to do so without drawing a whole bunch of stuff because of Ohm's Law podcast listeners. You want to be able to understand it as well. So basically, pulse density modulation is a 1-bit system. It uses 1 bit on and off, and it creates sound digitally by making more or less numbers of those 1 bits, denser or less dense. So when a loud voice comes up, the density, the number of 1 bits goes up dramatically. So if we were to look at it, there's a clock running, as you point out, at millions of times a second, about 11 million times a second. And if there's no sound, the clock is running, but there are no bits. The bits are all 0, okay? Now, as a little bit of sound starts coming in, like, I'm just gonna, thank you for turning the air conditioning off. I'm just gonna make a very low sound. There will be very little density coming in at the frequencies that I'm at. So you would see all of a sudden sporadic bits showing up. And when we play those sporadic bits back, it makes a very low voltage, which moves my speakers a very little bit, and I hear a very little bit of sound. If I have a very loud sound, now the density, still we're at this 11 million times, very steady eddy clock is going, and again, no 1 bits are happening, essentially. If there's no sound, but now if I make a loud sound, now we're going to have a very dense group of bits that are appearing, because those the density is what we're eventually going to turn into a music signal. So greater density has more energy, and it makes for a higher waveform, and fewer bits has lower density and therefore less energy. Now and that's DSD, pulse density modulation. Go on to Google and you can see some examples. It looks very much like analog. It's as close to analog, which is why you like it, much closer to analog than PCM ever will be, your 192 or 12496. Pulse code modulation always has bits going, and it looks like just a computer stream. You can't tell anything by looking at the stream, where with DSD and pulse density modulation, if you look at it, you can actually see the waveform by the greater density and the lower density of these 1 bits. In PCM, you can't tell. It just looks like computer gobbledygook. And here, this is a code that represents different voltage levels of loudness. So a very high number in this coding scheme makes for a very loud sound, and a very low number makes for a very low sound. And if we hit that 11,000 times or 11 million times a second or whatever, this is 44,000 times a second for a word, and we're not going to get into all that. But so you got the same sort of clock, and it's giving you the scale of what voltage to hit according to this code that represents higher and lower numbers. And that same code could be used to do arithmetic. That same code could be used to display video or play music. And it's the basis of all computers, is this pulse code modulation, if you will, this binary system, where pulse density modulation, PDM, and DSD is much closer to analog, and why we use it here exclusively at Octave Records. Hope that helps. Okay, bye.